Now we will have a look on the first part of the CRO, the electron gun. It's a modified version of the cathode ray tube. The first modification is made to the anodes. The anodes here are two hollow tubes instead of a closed plate. This is to allow the passage of the accelerated electrons through it to the deflection system. The second modification is adding a grid. The grid is a metal ring that is connected to a negative potential. This negative potential is controlled by a controller button. On the interface of the CRO, this button is the brightness. Adjusting the button will adjust the negativity of the grid, and hence the amount of repulsion between the negative grid and the negative electrons. This in turn controls the thickness of the beam of the electrons, which finally affects the brightness of the spot that will appear on the screen at the end. And this is simply the function of the electron gun. The second part of the CRO is the deflection system, a system that is responsible for the deflection of the beam of electrons from its original straight line path. The deflection system consists of two parallel horizontal plates named as the Y plates. The Y plates are electrically connected to the interface through two openings named the Y input. This is where we apply our signal, or the voltage to be drawn by the oscilloscope. The signal can be as simple as a DC battery, or as complex as sound captured by a microphone. Also, they are connected to a button to control the amount of deflection by the Y plates. This button is named as Y gain, or sometimes the voltage scale. As a simple example to understand the function of the Y plates, let's connect a DC battery to the Y input. This will apply a voltage on the two plates, so the upper will be positive and the lower is negative. This causes the deflection of the beam of the negatively charged electrons upwards, repelled from the negative plate and attracted to the positive plate. For more understanding, now reverse the connection of the DC battery. The plates will reverse their potential and the beam will be deflected downwards. This appears on the screen as a spot that is lower in position than the center of the screen. Remember that if the battery is removed and no signal is applied to the Y input, the bright spot will return to the center of the screen. The second part of the deflection system is the X plates. To understand the basic rule of the X plates, we must remove any signal from the Y plates. Unlike Y plates, the X plates are not controlled by external signals or inputs. X plates work by a signal from inside the CRO. The value of the signal is controlled by a button on the interface. This button is named as the time base. As long as the time base is off, there is no voltage applied to the X plates, and the spot is in the center of the screen. When the time base is having any value other than 0 or other than being off, an inside signal from the CRO named sawtooth voltage. This voltage causes the deflection of the beam across the screen, left and right with high frequency. This will appear on the screen as a horizontal line. The third part of the CRO is the fluorescent screen. The screen is covered from inside with a material that is sensitive to the electrons. When electrons fall on the screen, it gives a bright light in the position where the electrons hit the screen. This appears from the outside as a bright spot. The screen is divided into squares like a graph paper, so we can take our measurements as we will see later in the examples. The scale of the screen is controlled by the Y gain and time base buttons, where the intensity of the spot is controlled by the brightness button. These examples will explain what happens inside the CRO by applying different signals on the Y input. Remember that we said before that the signals to be studied are applied to the two openings of the Y input, which applies the studied voltage to the Y plates. Example number 1. Here we will remove any inputs from the Y input, and the time base is off. This will show a spot in the center of the screen. This is because the beam of electrons is not deflected anywhere, so it falls on the center of the screen. Example number 2. In this example, no signal or voltage is applied to the Y input, but the time base is now turned on. This will change the spot to a horizontal line. This is because on turning the time base on, a voltage from inside the CRO is applied to the X plates. This voltage is named the sawtooth voltage. It causes the deflection of the beam left and right across the screen with high frequency. What you see now is a very slow motion. The reel is much faster than this, and what you see now happens 50 times in 1 second. This appears on the screen as a horizontal line. In the third example, the time base button is turned off. The horizontal line is now again a spot in the center of the screen. But now a DC voltage is applied to the Y input by connecting a 3-volt DC battery. Because of this connection, the beam of electrons will be deflected upwards. This is because the upper plate is now positive and the lower plate is now negative. If the Y gain button is adjusted to 1 volt per each square, the spot will appear on the third square on the screen because our battery is 3 volts. Example number 4. Now we will reverse the connection of the battery. What will happen now is that the Y plates will also reverse their potential. The top Y plate, which was positive, is now negative, and the bottom Y plate, which was negative, is now positive. This will cause the deflection of the beam of electrons to be downwards instead of upwards. So the bright spot will be shown on the third square on the screen, but this time below the center of the screen. Remember that the time base which controls the X plates is still off. Example number 5. Now we will replace the 3-volt DC battery with a 5-volt DC battery. This will also make an upward deflection, but this time the deflection is greater because of greater potential difference of the battery. If the Y gain button is still adjusted to 1 volt for each square, the spot this time appears on the 5th square, not the 3rd square as previous. Similarly, if the polarity is reversed, the deflection will be downwards, not upwards. Example number 6. In this example, the 5 volts battery is still connected to the Y input. But now the time base which controls the X plates is now on. This will change the spot on the square number 5 to a horizontal line because now we have an upwards deflection by the Y plates. In the same time, the X plate causes the continuous left and right deflection across the screen. This causes the horizontal line. Example number 7. If we reverse the connection of the battery, the line will now be at the bottom below the center of the screen. Changing the scale to a smaller value will cause longer line. Example number 8 is totally different. The X plates are now off by turning the time base button off. A 5-volt AC supply is now connected to the Y input. Remember that AC is a voltage or current that continuously and rapidly reverses. This causes the beam of electrons to deflect up and down rapidly due to the rapid reversing of the voltage and hence the charge on the plates. As the time base is off, so no horizontal deflection by the X plates. The signal will be seen on the screen as a long vertical straight line in the center of the screen. The value of the voltage is measured by the amplitude, which is from the center point of the screen to the top of the signal. Here the screen shows it is 5 volts. Now the last example, number 9. The AC voltage is still applied on the Y plates through the Y input. But now we will turn on the time base button. This will change the signal to take the sine wave shape. This is because the up and down deflection caused by the AC on the Y plates is accompanied by the horizontal deflection across the screen caused by the X plates. This will be seen on the screen as a wave. This part will show the main controls of the CRO. The first control is the time base, and it controls the scale settings of the X-axis, which represents the time axis. It can make the signal wider or narrower for easier readings. Large scale causes more waves to be on the screen. A small scale causes less waves to be on the screen. The second control is the Y gain, or sometimes referred to as voltage scale. And this controls the scale of the Y-axis, which represents the voltage axis. Larger scale causes smaller amplitude, and small scale causes greater amplitude for easier reading. The third main controlling button is the brightness, and it clearly controls the intensity of the trace shown on the screen.